Assalamu alaikum students. Welcome to the ChemQuest and another review of paper review series. As you can see that this review is for Advanced Inorganic Chemistry 2 of Government College University Faisalabad. Paper code is Chem 502. As you can see that initially this is an MCQs type of paper. Total marks of the paper are 20 and time for these 20 MCQs is 30 minutes. I must say that a comprehensive study is needed in order to attempt this paper. This paper is quite important for PPSC exam as well, as you people will be aware of the fact that PPSC chemistry test for lectureship is going to be held soon. So if you are interested in attempting this exam, I must say that you should go through this MCQ type paper and should listen carefully to the explanation which I will give in the case of most of the MCQs. So let's start. The first MCQ is, which one of the octahedral complexes of ions has maximum loss in crystal field separating energy for SN1 mechanism? So there is a lot of information in this MCQ. So first of all, we will look into octahedral complexes. These are the complexes in which the coordination number of the complex is 6. And then we will look into the options. After we will see what is CFSE. CFSE actually is crystal field separating energy. And what is crystal field separating energy? This is the energy which is needed in order to separate the 5 d orbitals into two sets, that is T2G and EG. For SN1 mechanism, actually we will refer to high spin complex. Actually in the case of octahedral complexes, most of the complexes they are of high spin mostly, although exceptions are there. Low spin are also possible, but for SN1 mechanism we will go for high spin complex. So if we talk about high spin complex, then for octahedral complex in which there is configuration of the metal atom is D3, then it will have maximum loss in crystal field stabilization energy. So if you are more interested to go into deep, then you should go for the values or for the formulas for the calculation of crystal field separating energy for octahedral complexes, and then you will come to know that in case of octahedral complex, T2G orbitals, these are stabilized by minus 0.4 delta node, while EG orbitals, these are destabilized by 0.6 delta node. Delta node is the value of crystal field separating energy. We have to sum up actually the stabilization and destabilization energy, and in case of D3 we will get the maximum value, which is minus 1.2. That means the correct option is D3, right? And the next one is MCQ number 2. Which one of the complex has effective atomic number value of 54? So in order to get the value of effective atomic number 54, if we look into the options, option A is the correct one. And what is this rule? That we will sum up the atomic number of molybdenum, which is 42, and the number of electrons which are contributed by these 6 carbonyl ligands. So these 6 carbonyl ligands, they will add 12 electrons. So the total value will be 42 plus 12 is equal to 54. So option A is the correct one. MCQ number 3. As a result of complexation of metals with carbonyls, carbon-oxygen bonds become longer. So when there is complexation of metals with the carbonyls, then actually the carbon-oxygen bond of carbonyl group, it is actually elongated. That is why option B is the correct one. MCQ number 4. Which one of the d orbital is empty in labile inner orbital octahedral complexes? So we have here the options A, which is dxy, option B dx square to dy square, option C dz square, and option D is both B and C. So option B and C, that is dx square to dy square and dz square, both are correct. Because these are the high energy orbital as a result of crystal field splitting, and we have another option which is option D, that is both B and C. So the option D, which is both B and C, this is the correct one. MCQ number 5. Which one of the solvent has high value of dielectric constant? So dielectric constant, it depends upon electronegativity difference, and electronegativity difference is highest in case of hydrogen cyanide, and I have given here the electronegativity values of each of the choices. So for BrF3, the dielectric constant is 0.001, for HCN 95.4, for HF 84, and for water the dielectric constant value is I have given here 80. So the highest value is HC for HCN, and option B is the correct one. So MCQ number 6. Which one of the solvent is used in the synthesis of Friedel-Crafts reaction? This is like actually kind of silly question, because in options solvent is not given. Actually, if you see the options, these are quite silly options: H2SO4, HF, SO2, H2O. There is not any single option which is correct. Actually, in Friedel-Crafts reaction, the solvent used is nitrobenzene, which is not given here. So I will actually give number to all the students for this MCQ. That is, one number will be awarded to all the students, because no choice is correct in the answers of this MCQ. So all the students will be awarded one number, right? Okay. The mercury halides melt with the formation of discrete molecules. The mercury 2 halides, actually, mercury 2 halide, then it will mean mercuric chloride, which is actually a HgX2, right? When it will fuse, it means that it will be present in pure form, that is HgX2 plus HgX2. So I have given here the equation for this fusion. So the correct option is HgX plus HgX3 minus. So this is the correct option, which is A. Then we have MCQ number 8. Ammonia unable to dissolve highly charged species due to the correct option is low dielectric constant. So ammonia will be unable to dissolve highly charged species due to low dielectric constant. Highly charged species, actually they will have high dielectric constant, and as we know, the principle, according to the principle, like dissolve like. So a highly charged species will have high dielectric constant. So the characteristic because of which ammonia will be unable to dissolve highly charged species is low dielectric constant. So that means option B is the correct one. So MCQ number 9. Which one of the following species will act as an acid in liquid BrF3, that is boron trifluoride? So the species which will act as an acid in BrF3, here I have given the equation. When BrF3 will autoionize, then there will be the production of BrF2 plus BrF4 minus. So the species which will produce BrF2 plus ion in BrF3, these species will act as an acid, right? And the species which will produce BrF4 minus ion in this solvent, they will act as here I have written base, right? The option D is the correct one, because when we dissolve SbF5 in BrF3, here I have given this reaction, that is BrF3 plus SbF5, then it will produce BrF2 plus SbF6, that is it will produce BrF2 plus, which is and the species which will produce BrF2 plus in BrF3, it will act as an acid. So that is why the correct option is D. I hope that you people have understood. So MCQ number 10, which one species is produced when metal dissolve in liquid ammonia? So option A is the correct one, which is ammoniated electron, that is ENH3X. So this is the correct option. MCQ number 11, which one of the solvent is best in the preparation of halogens? So option A is the correct one, which is molten salts. Okay, MCQ number 12. Which one process is difficult if used a highly viscous solvent? So actually precipitation complex shows substitution reactions more slowly. So here I have, you can see I have given star 1. It means its explanation I have given at the top. So the correct option is magnesium hexaaqua cation. That is this complex sign. This will give substitution reaction more slowly. The reason is rate of water exchange is very high for alkali and alkaline earth metals, except for Be plus 2 and Mg plus 2 ions. Okay. It means that water exchange rate, this is very high for alkali and alkaline earth metal, with the exception of Be plus 2 and Mg plus 2. So if we look at the options, we have calcium, strontium, or all of these. But we have here the option magnesium, which have the slow rate of water exchange among alkali and alkaline earth metal. So the correct option is A. I hope that you people have understood. So now we have MCQ number 14. Which one of the complex has higher value of frequency in IR spectrum carbonyl for carbonyl centimeter inverse? Here it is given centimeter inverse, that means IR frequency, and the correct option is C. And the complexes here given Cl, CO, this is chloro, cobalt, penta, carbonyl, bromo, cobalt, penta, carbonyl, iodo, cobalt, penta, carbonyl, both A and B. So the correct option is C. And then we have MCQ number 5. If you want explanation of this MCQ, which is 14, let me know, then I can explain. Anyways, option C is the correct one. And then we have MCQ number 15, that is, which one of the complex has EAN value 86? So this WCO5, that is tungsten hexacarbonyl, it has the value of EAN value of 86, and the formula is same as I have explained on the previous slide. Then we have MCQ number 16. Which one of the following is used as mixed solvent? So the answer is straightforward, dioxane plus water. We have studied this in the class. MCQ number 17. In which energy lability of complex depends upon A. reaction energy, B. activation energy, both A and B, D. solvation energy? The correct option is B. Lability of the complex, actually it will depend upon the activation energy. Lower the activation energy, more labile the complex will be. Then we have MCQ number 18. The complex CON3O4N show structure in solution, cyclic, needle-like bridging, both A and B. This is again like confusing type. I have search a lot, and the information which I found, the geometry of this complex is distorted pentagonal bipyramidal geometry. Distorted pentagonal bipyramidal. So, so it can be bridging. C is the correct option because pentagonal bipyramidal geometry can be bridged. Maybe I think I should award this number also to all the students because this is quite confusing, and also this is quite far from the syllabus of GC University. So hopefully I will also award this number to all the students. Then we have option MCQ number 19 in CON 304. Complexes stretching frequency appear at 1481 and 1164 centimeter inverse. Shows nitrosyl group, terminal, linear, coordinated, and D option have both A and B, which is terminal and linear, right? So in case of actually a nitrosyl group, uh, uh, the linear nitrosyl group, right? It will appear frequencies, stretching frequencies for a terminal or linear nitrosyl group. It appear as 1481 and 1164 centimeter inverse. So if the nitrosyl group is linear, then it must be terminal as well. So both A and B, the option D is the correct one. Which one of the ions is more labile towards reaction? So option D is the correct one because option D is the LF6 minus 3, and aluminium, as you people know, is the most reactive one. So in all these four ions, this AlF6 minus 3 ion, this is more labile, or you may say this is more reactive um, or towards all the reactions. So this was all about the MCQs, types of paper, solution of MCQs. I hope that you people have understood. If any problem, you can ask, please. This is the subjective type of paper, and this is quite straightforward. We have covered all these questions in the class, so I hope that you all have done to the best of your knowledge. So question number 2, A part, discuss the bonding situation in metal carbonyls based on IR spectroscopy. So this is straightforward. Actually, all these questions are straightforward. Explain mechanism of nucleophilic substitution reaction in octahedral complexes. The good thing is all the questions, these are well within the prescribed syllabus of GC University, which is quite good. Question number 3, explain the important reactions take place in liquid CH3COOH. And then we have various types of classification of solvents. This was quite easy. Write down methods of preparation and reactivity of metal carbonyl hydride, although I mean it is quite tricky because we have to memorize all these reactions, but it is within the syllabus. Then B part, write down mechanism of dissolution of a solute in liquid HF. This is straightforward. Explain direct transfer reaction, redox reaction in octahedral complexes in detail. We have done that. Explain the labile and inert complexes according to VBT theory. So all these are well within the syllabus. So thank you very much for listening to this review. So if you have understood and enjoyed, please subscribe, like, and share for more such reviews. Thank you very much, and Allah Hafiz.